the area under the simple curves. To start off with this topic, I would like to give you an example of a curve. Since we'll be dealing with x and y, which is nothing but 2D geometry, we'll be considering the quadrants of the graph. Consider a curve that is plotted in one of the quadrants. For our simplicity, let us take the first quadrant. Consider that curve is bounded by a region at the points A and B on the x-axis. So you have to find the area that comes under the curve up to the x-axis. As you can see, the value of x changes from A to B. As the value of x changes, the value of y also changes. So we can tell x is an independent variable and y is a dependent variable. Well, the curve also has an equation. Let us consider to be f. Since the value of x changes, the value of y changes, and also as the value of x changes at every point, the value of the curve also changes similarly. So what we can tell is that the value of y changes in terms of x as well as goes to the same function. So we can tell the function of the curve to be f of x. And thus the value of y at each point of x can be considered to be f of x, which is nothing but y is said to be the function of x. Now we know the equation of the line, that is y is equal to f of x. So how do we approach or how do we calculate the area that comes under the curve? So to find the area that comes under the curve, the approach was to divide the whole area into thin slits of rectangles, and then when you add all these thin slits together, you get the curve. So if you consider this thin slit rectangle, the arbitrary width of this rectangle is considered to be dx because it changes as per the x-axis, and the arbitrary length of the rectangle is considered to be y. So now we have to calculate the area of that thin slit rectangle. So what is the area of the rectangle? The area of the rectangle is nothing but length into breadth. Here the length is given by y and the breadth is given by dx. So thus the area of one single thin slit is given by y into dx.